Okay, the first instruction that we did today had to do with organic chemistry. And this was our homework from the weekend, which I gave you without instruction. And most of you fell flat on your faces as you were trying to do it. So we're going to try to get a better understanding now of how this works. What we just did before turning on the recording is we went and looked at page 702 to see what substituents were named by and how they were named. And then we also looked at page 700 to see what the base names are of the alkanes, or they call them the root names. Okay, so these guys, this is where you're going to find the root names. And this kind of a structure is called a carbon backbone. Okay, it's also called a skeleton equation. Okay, they go both ways. However you call it, this particular structure is what? 4 carbons. I'm not showing any of the hydrogens, but they're actually there. This is butane. Now, before I go any further, let's show this with hydrogens. And how many hydrogens are there in butane? You see what it is? The number of carbons times 2 and add 2. Okay, so it's 4 times 2 for the carbons. So we have 8 there, and then we have 1 on each end. Each carbon, and this is what you have to keep in mind when you're trying to draw different kinds of structures, which we'll be doing later. But for right now, I just want you to know that all carbons need 4 bonds. They got to have 4 bonds. Okay. Which is not terribly different from the Lewis structure thing, is it? Isn't that right? Each bond has how many electrons? How many in a stick? 2. Yes.
So why is it that for methyl and ethyl they have that one bond that's not really bonded to the
Well, what do you mean?
like methyl, isn't it like carbon in the
Methyl. You have a carbon in the middle, and you have 4 carbons or 4 hydrogens around it, like this. Who do I have here? What is this molecule right here? Huh? 1, 2, 3, 4, 5, 6 carbons, and 6 is for hexane. Now, let's put a simple substituent on it. Okay, who is that? 1 carbon substituent. No. Who is the substituent? This guy right here. Come on, folks. What is the substituent? Page 702. 1 carbon. Methyl. Okay, now, which end is he closest to? Okay, he's closest to this end. So this guy's carbon 1, 2, 3, 4, 5, and 6. All right? So since this guy's methyl, here's how we're going to name him. He is on carbon 2, correct? 2-methyl. Sometimes people put a dash here, sometimes they don't. I don't really care. I just want you to get the idea of how the substituents work. So this is 2-methyl, the name of the longest chain. I'm going to circle the longest chain. Okay? And he's on carbon 2 of what is the longest chain? How many? Which makes it hexane. 2-methyl hexane. Same molecule. I'm adding another substituent. Now what do we do? No. You're making a mistake that lots of people make, and I'm glad you did it. Not that I'm glad you're making a mistake, but I'm glad you did that because a lot of people look at that and they say methyl. A methyl is this, or an ethyl, I'm sorry. This is ethyl. If I were doing an ethyl, I would do it like this. That's an ethyl substituent. 2 carbons because that's what ethyl is. Okay? Does that make a little bit of sense? Okay. Now, let's see if I can get rid of that expeditiously. Yes. Where'd you get methyl from? Okay, methyl is a 1-carbon substituent. Remember, I held this guy up and I said, what is this? Okay, I'm holding up a little model right now of methyl, which is 4 carbons around the central atom minus 1. Because methane would be the guy that has the 4th hydrogen on there. Okay? When I take that 4th hydrogen off, now I have a methyl group, and that's what I'm sticking in at any particular place here. Okay? Did that make sense? Yeah. Okay, good. Now, let's look and see how we deal with this in this second case where we have 2 methyl groups on the same carbon chain. Where's the first one on? Carbon 2, and where's the second one? 2, 3. Okay, so I have to say 2, 3. How many of the methyl groups? 2. So this is di. That's where the di comes from. And then we say methyl. And it's still a hexane. Make sense? Okay, let's extend the page a little bit. Let's do another one. Now, with this guy, we're going to start out with a nice long one. Here we go. Are you ready? I'm going to put the substituents in a different color. Let's try it this way. Okay. Now, who's the longest chain? Who is it? Nonane. Yes, this is nonane. So nonane because non stands for 9, and there's 9 in the longest chain. So what I'm going to do is I'm going to circle the longest chain. Okay? Now I know where my longest chain is and which end has a substituent closest to it, left or right? The left. Good. So this guy's going to be number 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. Now, when we have more than one kind of substituent, we put them in alphabetical order. Okay, so let's name the substituents that we have. What are the substituents? Ethyl, and we also have a methyl, or 2 methyls. Okay? Ethyls and methyls. Let's name them. Who do we do first? Yeah, but who do we do first? Ethyl or methyl? Ethyl. Okay. Let's start out with ethyl. Now we know what the substituent is. How many of them do we have? Oh, there's 2 ethyls. Let's circle them. There's 1 ethyl. There's an ethyl. Well, Mr. Wigger, What's going on here? This guy's pointing straight down. This guy's off to the side. Yeah. That's right. That's the way it works. They're both ethyls. They're both 2 carbons long, right? Each of them is 2 carbons long. So we have, oh, and who's going to be carbon number 1? Left or right? So from this end, that's going to be carbon number 1. I got lucky because I just numbered 1 to 10 or 1 to 9. I should have looked first and said, okay, I go in 1, 2, 3, and I get an ethyl group. If I come in from the right end, I go 1, 2, 3, 4 before I get to a substituent, which is a what group? That's a methyl group. Okay. So my ethyls are on what 2 carbons? 3 and 5. Look at it as a street address. Okay? The longest chain is the street, and we start from the end of the street that has a substituent closest to it. Okay? And that's how we number the post office boxes, or the postal address. Okay, so this is 3, 5. How many ethyls? Diethyl. And the longest chain is none. Starting to make a little bit of sense? Cool. Okay, when I did my first naming on this, I'm actually going to get rid of that because I left out my methyls, and you can't do that. So this is 2,3-diethyl. We're okay at that point, but now we've got to do the methyls. So the methyls are on what 2 carbons? Yeah, 4 and 6. So this is 4, 6. Thinking of the dimethyl. Okay, 4, 6, and what's the prefix? Di. Methyl. And then what? And the nonane. Okay, there we go. This getting a little less mysterious about substituents? Yeah. All right, let's try another molecule. Okay, here's a new fun molecule. If you have your textbooks open to page 702, I want you to look at the substituents that we have now, and let's figure out, first of all, what end is going to be number 1? Right? Okay, going from the right, I count 1, 2, 3, 4, 5, and I'm into a substituent. Let's go to the left end. 1, 2, 3, 4, 5. Oh, goodness. Whatever will I do? It doesn't matter. It doesn't matter. The purpose of the naming is to be able to draw a molecule that is accurate. So, I can choose. What end do you want to be number 1? You want the right? How many want the right? How many want the left? Of those who voted, the rights win. Okay, so this guy, let's go ahead and number him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have I got the longest chain? Okay, just for fun, I'm going to take a little side trip here. 1, 2, whoops. 1, 2, 3. Now, is that still the longest chain?
Yes.
No. Count with me. I'm going to redo these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a 12 carbon chain. But wait a minute, it turned down, right? So, huh? Oh, well, these guys, they're not close enough to the end to make a longer chain. I did that on purpose. Okay? But this guy is long enough that he modifies the length of the chain. We're not going to mess with that right now so far as the naming is concerned, but I just want you to know that that sort of stuff is going to happen. And so you have to watch very carefully. And so far as today is concerned, I'm simply going to take the simplest cases and deal with those. So we'll make this longest chain as I originally had it here. And let's put a circle around it. And you're going to find out how important circles are in just a minute when we get into the homework that you're working from tonight. So let's go ahead and look at this now. And what are the names of our groups? First of all, who's on 5? Huh? Propyl. Good. Who's on 6? Propyl and? This baby is not propyl. Are you on page 702? It's isopropyl. Why? It's hooked in the middle. This guy right here is hooked on the end. This guy is also hooked on the end. Okay, so let's name the substituents. We have propyls. And what else do we have? Isopropyl. Who comes first? Isopropyl or propyl? Isopropyl is first, indeed. So let's name this little guy. Isopropyl's on which carbon? 6. Okay, so isopropyl, 6. Isopropyl. That takes care of this guy. Check him off. Now we got to do the other 2. They're on what 2 carbons? 6 and 5. So we do 5, 6, what? No. Di, good. Dipropyl. And the final name? Decane. I want to do one more little thing that's going to throw you a little bit, and we want to get used to it. So, any questions on how I got to the names on this guy? Okay. And that 702 is where the chart is. Now, let's do another one. And all right, now we have to figure out who the longest chain is. Okay, the longest chain is going to be starting at any end, going to any other end. So let's start the traditional way that you think. If I start at the far right, at this carbon right here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? That is a nonene. All right. Now, I've got to go, I'm going to start at the same carbon and go to the left one, and then I'm going to go down. So I go 1, 2, 3, 4 in what looks like an ethyl group, huh? That's obviously not the longest chain. So let's take another chain. Let's start right here. 1, 2, 3 to get to the main, what looks like the main chain. Then I'm going to go to the right. 4, 5, 6, 7, 8. Well, that's not longer. I could do the same thing on the ethyl group that is down below that guy, and I would get the same result. How about if I start right here? Now, let's try. 1, 2, 3, 4, 5, 6, 7, 8. So far I've gone to the right only, and now I'm going to go down. 9, 10. Oh, this is a decade. But just to tweak your mind a little bit, instead of starting with this guy, I'm going to start with this guy. Okay? And we're going to make the longest chain. Are you ready for the longest chain? Here we go. Do you see why I'm drawing this longest chain? Now look at it. Do you see how the substituents pop out? Let's count it. Let's go from the far left end. I'll start right here. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the longest chain. You can't go from right to left because if I start at the far right, which is right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9. Either this carbon or this carbon could be in that longest chain. Wouldn't matter. I went down because I wanted to tweak your mind a little bit so you can start to see this. Are you starting to understand why I start organic chemistry a day or two before we get into the tough stuff? This stuff can drive you nuts. Okay? We will have some things that look absolutely gargantuan. I call them hairy monsters. Okay? We will get those. But for right now, I'm keeping it relatively simple. Now, let's make a list of our substituents. What's our first kind of substituent? Okay, let's circle these guys in green. That guy's a what? And is this guy the same kind? Yeah. Okay, so we have methyl. What else do we have? Okay, here, yeah, this guy's an ethyl, and this guy's an ethyl. Okay, so we also have ethyl groups. Now, we're going to name this guy. So let's extend the page a little bit so we have a little bit more room here. And who should I start with? Ethyl. Okay. So where are the ethyls? Which end do we want to be number 1? The one on the left has to be number 1. Okay, because this guy right here is only 2 in. And this guy over here is 1, 2, 3 in. So this guy was 3 in, and this guy is only 1 in. That makes that end number 1. And so this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Start up. Okay? So, where are my ethyls? 5 and 5, yes. So you have to put 5 2 times. 5, 5, di for 2, so there's 2 ethyls. And where are my methyls? On which 2 numbers? 2 and 8. Yeah. So it's 2, 8, di, methyl, and the length of the longest chain is decane, 10. Now we're dealing with tonight's homework. This is the Zumdahl handout that was in Thursday's homework page. And you will see a link to get this particular picture. So this is number 25, which was the first of a number of structures that we were going to name. And let's figure out, first of all, the longest chain. And Okay, here we go. We're going to circle the longest chain. And Justin is going to do that for us. Okay. That's your longest chain, huh?
Yeah.
No.
Oh, I think I.
You want to change your mind here? Okay, just a moment. Yeah.
Oh no.
Huh? Keep going. There we go. Yay, give me a hand. All right, that's the longest chain. It looks like an ethyl, doesn't it? Doesn't that look like an ethyl substituent? Yeah, yeah. So, now, this is not the carbon backbone that I was showing you before. This is the condensed molecular formula. And this shows you the hydrogens, which I think is a little bit more confusing, don't you? So if you are getting confused by the hydrogens, what I'd recommend that you do is simply get yourself a drawing that you make and then look at it again without the hydrogens. And that sometimes will get you a little bit straighter in your thinking. And so let's go ahead with that as the longest chain. And Justin, which end is going to be the longest, or which end is going to be the end that we want to start with number 1? Would it be here or here? You want to be on the right, okay? I want you to count from the right and tell me where your the methyl group is. What carbon is it on if we start from the right? Uh-huh. What carbon is it on? One. I just pointed at him.
Oh, maybe we start on the bottom.
Oh, yeah, maybe we do. Indeed we do. Because we go in 5 from this right side, but if we start down here, we're going in 1, 2, 3. And so the one down below that looked like a methyl group originally, which wasn't a methyl group, of course, is now going to be our actual part of the chain. And this will be carbon number 1, 2, 3, 4, 5, 6, and 7. So, what are our groups that we're going to have to be considering here? Only one, correct? What carbon is he on? And this one goes to Tina. Could you tell us what carbon we're on? Huh? Look. Look. What are you looking for? Look up here. Tina, look on the board. What's carbon number 3? What's on? Well, I just told you. Okay, look, I've got them numbered for you. See? This is carbon 1, 2, 3, and that's where your methyl group is. This guy is your methyl group. Okay, so how are we going to name him? Start that way. What carbon is methyl on? Well, I just told you. Hasn't changed. Hasn't gone anywhere. 3. Okay. So, what's the first thing we do when we name an organic molecule? Huh? Tina, you need to be listening more closely. You're doing something else, and that's why you don't know what you're doing. Michael? 3. Then what? Why? Why do you put a second 3 in? Why? Why are you thinking that you'd use a second 3? Are there 2 of the same number on number 3? Okay. How many are on number 3? Just 1. So we put 3. What's the name of the group? Okay, methyl. And how long is the chain? 7. So the longest chain is 7. How do we name the final name? Heptane, absolutely. Tina, does this make sense? Tina, how do you get the name? You name the longest chain by using page 700's chart. Page 700's chart, yes.
Do the hydrogens like affect the name?
Hydrogen has nothing to do with the name. That's why I use the carbon backbone. It makes life easier, much easier. Okay, yes.
So whatever drawn in on the homework, you can just do it.
Draw it on the homework without the hydrogen. I will discuss with you another day how to figure out how the number of carbons will change with where the thing is, where the carbon is in the chain. Elmira? Because you go to page 702 and you look at that chart and you'll see that this is the methyl here is only 1 carbon long. Don't get yourself mixed up with all the hydrogens. That's why I like the carbon backbone. That's why it's a good idea to recopy this problem with just the carbons and the one line between each carbon. And then you have the stuff that will give you everything you need to be able to name that dude. Yes. Michael? How do you know where to count from? In this molecule, we call this carbon right here number 1. We did that because we counted from this end and we got to 3 carbons and there was a substituent. Now, if you count, yes, you count from this end and that substituent is on 1, 2, 3, 4, 5. It's the end that has any substituent the closest to it. So if we had a substituent here on number 5, counting from this end, 1, 2, 3, we would be able to, what we've labeled number 5 could have actually been number 3 if we had a methyl substituent on that carbon, this guy right here. Okay. Are we getting there? Yeah. Make sense? Yes. Yeah. Did anyone else have a question on this one? Okay, great. Let's go on. Let's go to letter B. And on letter B, Seraphin, would you come on over and show us the longest chain? Hi, Seraphin. Looks like you've been asleep. Yeah. Just a second. Let's go back to notebooks so that we don't keep having this stuff disappear on us. Oops. Yeah.
How do you do that? Because it's like both people.
You figure out who's the longest chain. Start at the far left end next to the letter B and count.
1, 2, 3, 4.
Okay. Now count going down.
1.
So across and down. Okay.
1, 1.
I think I know this.
1,
2.
2.
I count it.
Now, instead of going across, go down.
1.
No.
3.
1,
2.
2.
3.
This guy's 3. Is that the longest chain?
No.
No. So let's start here again. 1,
Oh, I get it.
2,
3, 4.
3. That could be number 4, couldn't it? 1, 2, 3, 4. So, does it matter whether we use this guy or this guy for 4?
No.
No, it doesn't. So it's your choice. Now you can be creative.
Okay.
You circle the one that you want. Ah, you want to be creative. Excellent. I love it. Okay. Now we get to give it a name. And by the way, the names will come out different depending on how we circle. Could be different. No, the names in this particular case would be the same, but sometimes they could come out different. Okay, so we have the longest chain. Now, let's see, Finn, tell us who's going to be carbon number 1. Come on up and show us. let's label carbon number 1. Okay, is it possible for another carbon to be carbon number 1?
Yeah, that one.
Okay, good. The guy at the other end of the chain could also be carbon 1. Why?
They both have the same subscript, so they're both equal. Sorry.
They both have the same subscripts?
Or are they both equal? No, because you could start from either side.
Either side, and you'd get 2 in,
Yeah.
and you'd have a substituent.
Why?
Excellent. What?
Why?
Why? Because you could start from either end. And here, start from this end. Just give it a nice little tap. Yeah, right here. Just tap it. Okay, right there. If that's carbon number 1, this guy's carbon number 2, and there's a substituent. Okay. Now, if we started from the other end, just a little tap, and this guy's number 2, and this guy would be the first substituent. So it's our choice. We can choose whoever we want. Finn chose to put number 1 where he did. Now would you number the rest of them? On down to 4. Okay. Yeah, it takes some getting used to. Okay, and there's our 4. Okay, we got 1, 2, 3, 4. All right. Now let's go ahead, and I'd like to have Junior come on up. You're the next card up, buddy. What are these 2 groups right here? What are these? What are those 2 groups?
Green groups?
Uh-huh. What are they?
Methyl.
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 Okay. So, where are your methyls? On which 2 carbons?
Where? Which one?
Which 2 carbons are the methyls on? This is one of the methyls. This is the other methyl. Which 2 carbons are they hooked to?
Down and down.
Okay, those numbers are
3 and 2.
3 and 2. So we're going to call that. Let's start naming it right here. Start naming it.
This is methyl.
I know it's methyl, but you have to say where the methyls are. That's how you start the name. They're on 2 and 3. So
2 methyl.
2,
Methyl.
comma, here, 2, comma.
2, 3 methyl.
There you go. Now, how many methyls total do we have?
2.
Okay. The prefix for 2 is
Di.
di. Methyl. Now, what's the longest chain?
And this one?
Uh-huh. Uh-huh. How many in the longest chain?
4.
4. 4 is for, what's the name for 4 of them?
4. Oh, and I don't know.
Methyl, ethyl, propyl.
Oh, I don't know.
Methyl, ethyl, propyl, starts with a B.
Oh, butane. Or
Butane. Mm-hmm.
butyl.
Methane, ethane, propane, butane. Okay, so this is butane.
Yes.
So, write it.
Okay.
B-U-T-A-N-E. Yep. It's okay. Here. It wouldn't make it wrong to write that as a capital, but the capital is not necessary. Okay. So, that's a good name. All right. Very good. Thank you. What I'm going to do is just 2 in each group here. Let's go back and look at the Elmo again, and let's get that up, and let's start with the group in 26. Okay, there we go. Let's get this guy. Okay. Let's go. Cool. Skip this now, and let's go back here. Great. Okay, so for 26, what do you say we do A and C? Let's do A and C on this one. Okay, Katie, you're on.
Where? Oh.
Okay, Katie, I'd like you to find us the longest chain.
For which column? A?
Letter A. Uh-huh. Okay, Katie has just circled the longest chain for us. And could she have circled a different chain and it still be correct? Okay, what could she have done? Straight across. Right. Okay, but she chose to be able to create, and that's just fine. I like that because it gets your mind tweaking a little bit so that you can see the longest chain is the longest chain no matter where it goes to or from. Okay? So, as we look here, if we called this guy the longest chain, then this ethyl group, what looks like an ethyl group, if this had been the longest chain straight across, this ethyl group would have been on which carbon? From the right. 3. Okay? From the left, which carbon would the ethyl group have been on? 3. Okay? And with the way that we've drawn it, where is the ethyl group? 3. You see, we could have done it either way and it would have been fine. Okay, so let's go on and give this guy a name. Nairi, give it a name. Yeah, sure. To name it, first of all, you're going to have to number the carbon chain. Number the longest carbon chain. No. Number it up there. Put numbers on the carbons for us, like we've been doing. Okay, you're going to call that 1. That will work, because we could go from either end. Either end, we'd get our, that's a 2. Do you want to make that a 2? Looks like a dot. And that's okay to identify it. We're numbering now. Okay? And, okay, go ahead, carry on. Okay, and keep going. 4 and 5. Okay, what group what is the name of that substituent with 2 carbons? No, it's not a di because there's only one of them. Methane, ethane, propane, butane. It goes in that order. 2. Ethane. But this is going to be an alkyl group instead of an ane. So we're going to call that, instead of ethane, it's going to be ethyl. I'm sorry? I know it's an alkane, but this is an alkyl group of an alkane, on an alkane. Okay? So this is called the substituent. Okay, what number carbon is the ethyl group on? 3, indeed. Okay, go ahead. Could you put that up a little bit? Because we're going to be doing some stuff down here. Let's kind of keep it up above the line. There you go. 3, go ahead. YL. That's right. Okay, 3 ethyl, and what's the longest chain? How many carbons? Methane, propane, butane, pentane. There you go. You got your pentane. Excellent. Pick your color.
Which one?
Before we name him, let's pick the longest chain.
No, but which one? This one?
Yeah, letter C.
Oh, C. Oh, is it just
Okay, what you want to do with this guy is rotating 45 degrees in your mind. And why don't you just go ahead and rewrite him?
like
Take one chain, 3 across.
One
Forget
chain?
about the H's.
oh
That's fine.
wait what do you want me to do?
Here, let's give you more room here. And that way you have lots of room to do this, guy. Okay? Now, write a 3 carbon chain. Put him right up here. 3 across. That's because he's on the wrong track. It's okay. Now, would that describe this?
Yeah.
Okay.
Oh, okay.
Now, folks, does this look more friendly?
Yes.
Yeah. Okay. What do you want to be the longest chain?
Really got it?
Yeah, it really doesn't.
Just be creative.
Oh, okay. You want to be creative? That's fine. I like creativity. Okay. Now, does it matter which end is 1?
No. Yeah, no.
Okay, fine. It doesn't matter in this case, does it?
No.
1, 2, 3. Okay, we got them numbered. Now, what are our substituents? Yeah, go ahead and circle. Circle the 2 substituents. Cool. What carbon are they on? Okay. Go ahead and name them.
These books, the guy, okay.
Start with the numbers of the carbons they're on. Hey, you're going to need more room than that. Yeah, start down here. No. What's wrong? Where's your blood? Why did I stop her? She wanted to say 2-dimethyl.
Yeah.
What's wrong with that?
It's 2-2.
It's 2-2.
Because there's 2.
There's 2 substituents on number 2. 2-2. Now you're dimethyl. It's so great to have you guys doing this because people at home are going to be doing the same thing in their heads and they're going to make the same mistakes and they'll have a chance to see what they did wrong, which is great. 2,2-dimethyl. Now we're not done.
Oh, is it?
What's the name of the longest chain? How long is it?
3.
Okay, it goes methyl, ethyl, propyl, butyl, pentyl. Propane. Propane. There you go. Propane. There you go. Okay, our last 2 problem sets are on actually drawing the formula for each of the following compounds and just do the carbon backbone. So we're going to start with 2-methylheptane. Now, I'm going to step you through, when I call you, I'll have you come up and we'll step you through how to go about doing this. Sean, you're going to be first. First is he's going to write the longest chain and may as well make it straight. Okay, so put it right next to the methylheptane, 2-methylheptane. Okay, 7 carbons, right? Okay, now, where is methyl going to be? No, bottom. Bottom or top, I don't care. What carbon? How many in? Okay, go ahead and put it on. Yep. You see what we just did? We just drew the longest chain, and we delivered the male. In this case, the male was who? Who's the male? Methyl, okay. And what house did he go to? Number 2, the White House, yes. Okay. And so that gave us 2-methylheptane. Pretty easy, huh? Okay, let's do the. And Kavan is going to do a 2,4-dimethylheptane. Yep. Okay, 7 again. Which end do you want to be number 1? Left or right? Okay, you're going to make the left side number 1 And you're gonna put a, yep. Could he have put his second methyl on top? Yeah, wouldn't matter. Yep. That's just fine. I think you guys can do the rest of these pretty well. You shouldn't have a trouble with them. I will give you 10 minutes to finish off the worksheet.